In this part, we want to focus on getting the direction of the current in the loop. So as the loop is going in, what's the direction of the current in the loop? If you want, we can do it in two ways. First, using Lenz's law. So what do you think the direction would be using Lenz's law? Well, what does Lenz's law say? As the loop is going into the region, is the magnetic flux magnitude getting bigger or smaller? It's getting bigger. So the induced magnetic field that's created by this induced current wants to be in a direction to prevent it from getting bigger. And so you want to make a magnetic field out of the page because the original magnetic field is into the page. So the induced magnetic field should be out of the page to prevent the magnetic flux from getting bigger. So what kind of current would make a magnetic field out of the page? This one. And you can check this by putting your fingers in the direction of the current. Your thumb points out of the page. That's a simple way to remember how to do it. So this is the direction of the current using Lenz's law. You can also the direction of the current using the F equal to QV cross B rule. If you imagine a negative charge inside the wire, what's the direction of the velocity of this negative charge? To the right. So V cross B is actually upwards, but the force is not V cross B, it's QV cross B. Since the charge is negative, then the force is actually downwards. So that means the velocity of the charges, the negative charges, is going to be downwards. That means the direction of the current will be this way. So it's exactly the same way we predicted before. Okay, what about when the loop is completely inside the region? What is the current when the loop is completely inside the region? Well, there's no current. There's F. So there's no current. And since there's no current, then we can't get any direction. So what happens when the loop goes out of the region? Let's use Lenz's law. When the loop is going out of the region, what's happening to the magnitude of the magnetic flux? It's getting less with time. So what does the induced magnetic field direction want to be in? It wants to be in a direction to prevent the magnetic flux from getting smaller. So that means you want to make a magnetic field into the page, the same direction as the original one, to prevent the magnetic flux from getting smaller. So what kind of current would make a magnetic field into the page? If you make a current in this way, put your fingers in the direction of the current, the thumb will point into the page in the direction of the induced magnetic field. Okay, if you want to use the QV cross B rule, also you can use it for this part going out. So the velocity of the charge is to the right, same way as before. V cross B is upwards, but QV cross B is downwards. So that means that the current is going to be in the direction opposite the motion of the negative charges. So the current will be this way, as we said before.